The lack of volume testing is a sure way to waste money on software development. If you skip this type of testing, there is a high chance that a few months after your web application's public launch, it will start to slow down drastically, even with a small number of users. Those users will get frustrated, leave for your competitors, and you'll lose money. This type of testing is called volume testing. Its purpose is to test the application's functionality under a large amount of data. Volume testing differs from load testing, where the focus is on how the application performs under a high number of simultaneous users, whereas in volume testing, the focus is on a large number of objects in the database. For example, if you're developing a project management system with a task search feature, I'd test the following scenario. How the search performs where there are 10 tasks, 100 tasks, 1,000 tasks, or 10,000 tasks in the database. You might say, wow, 10,000 tasks is an unlikely scenario, but I'll tell you this. In design and test lab projects, task count per project have already exceeded 2,000. Multiply that by 5 projects and voila! You got over 10,000 tasks in the database. Why would the search functionality slow down as the number of records in the database increases? Let me explain with a book metaphor. Right now, I have 2 books on my desk. If you ask me, Vladimir, can you hand me the book about personal productivity? I'll immediately grab it with my right hand and give it to you. I've handled your request in seconds. However, I also have 2 bookcases in my office containing more than 100 books. Now, if you ask me for the productivity book, I first need to recall whether I own it and then go through each shelf to find it. I've done this several times over the past month. If I vaguely remember where the book is, I'll find it about 5 seconds. But if I don't remember, searching could take several minutes. See? With 2 books, it's instantaneous. With over 100 books, it could take minutes. Now imagine looking for a book not in my office, but in a real library. The Kharkiv State Scientific Library holds 7 million publications across 13 storage floors and a building that's 76 meters tall. Do you think I could find the right book there in less than a year? In this analogy, the library is your application's database, and the books are its records. These records could be products in an online store, tasks in a project management system, users in a SaaS application, posts in a social network, clients in a CRM, and so on. Typically, these are entities that grow as your business scales. When your contractor delivers your online store or SaaS application, the database will have minimal data, perhaps just a few entries created to demonstrate key features. If the application runs smoothly with only a few test entries, there is no guarantee it won't slow down when the database contains 1,000, 10,000 or millions of records. To evaluate how an application performs with large datasets, engineers conduct volume testing. Here's an example of how we do it at Design and Test Lab. First, we analyze your business to determine which entities will grow over time. Next, we agree on database size requirements with the client. For example, for one online store project, we decided the application should run efficiently with 10,000 products in the database. Then we create automated scripts to populate the database with various products. It's not like we're going to do this manually. Once the database is filled to capacity, we begin testing key operations: creating, searching, editing, viewing, adding products to the cart, and so on. We verify that the online store handles all these requests within an acceptable time frame, say 500 milliseconds. To reiterate, the difference from load testing is that in volume testing we fill the database to its limit in test with a single user, whereas in load testing multiple users test the system simultaneously. If we notice that an operation is slow, for example, creating a product takes 500 milliseconds, but searching takes several seconds, that's a clear sign that the search algorithm needs optimization. After all, an online store where search takes several seconds is simply unusable, and users will flock to competitors' website and you will lose money. Why don't these search algorithms run instantly? Aren't modern computers powerful enough? This boils down to the concept of algorithm complexity. If the algorithm has constant complexity, it runs in the same time regardless of the data size. If it has linear complexity, the time required grows proportionally to the data size. For instance, searching a database with 1,000 records might take 100 milliseconds, while 10,000 records take 200 milliseconds. But with quadratic complexity, the time grows exponentially as the data size increases. Let me share a painful story about having to rewrite an algorithm created by a contractor I hired. We were developing a geographic information system to process algorithms on urban utility network graphs. My contractor developed the algorithm and showed test results. On a test network with 1500 elements, the function ran in 1 minute. We confirmed with the client that 1 minute was acceptable for this infrequent engineering task. I proved the contractor's work and paid him. Later, we went to the engineering office to deploy this geoinformation system. It turned out that the actual network for a city of 200,000 people had 50,000 elements, 30 times more than the test network. Even before running tests, I knew I'd messed up. The algorithm had quadratic complexity and I didn't expect good results. Sure enough, on the real network, the algorithm didn't complete in 1 minute or 5 minutes or even an hour. The client rejected the work, and I spent an extra week rewriting and optimizing the graph algorithm to ensure it ran in 1 minute on a 50,000 element graph, all at my own expense. My mistake as a manager was failing to clarify the expected database size for the algorithm and not requiring the contractor to test it with that volume. Now, to avoid redoing work, we test algorithms on large datasets right from the start. So, a major red flag is if your contractor skips volume testing. Key takeaways. To avoid stepping on this landmine months after your application launches, here are my key recommendations. First, define your business growth expectations. What database size will you need in the next 1 or 2 years? Second, agree on this requirement with your contractor before starting work. For example, the application must handle a database with 1,000 users and 10,000 products, ensuring product creation, editing, and searching operations respond within 500 milliseconds for 95% of requests. Third, ensure your contractor includes volume testing in the project plan. Fourth, review the volume testing results. Fifth, to avoid conflicts of interest, delegate volume testing to an independent party like us at Design and Test Lab. Sixth, don't accept or pay for work until your contractor achieves the required performance metrics. If you need help designing volume tests for your application or optimizing it, I'm always here to help you. My contact details are in the description. Subscribe, like, comment, share it with your friends, and see you next week. Bye.